Like that one. All right, ladies and gentlemen, we are going to jump around in the notes a little bit. Here's why. This first page actually uses skills you've already learned. The second page would be probably brand new to you. It's the last type of new factoring we learn. So I want to actually start on the second page so that I can stop and make sure to take time for questions. And then the first page is a lot of review. So hopefully that will feel much easier to work through. So on the second page, the last thing we look at is what do you do when you have 4 terms? And when you have 4 terms, you're going to use a process called factor by grouping. So go ahead, write that in, factor by grouping. The second page. We're starting on the second page so that I can make sure to really take time for questions. Now, in this last type of factoring that we look at, you do have to review a question we learned earlier on because we use that skill. So here's the review question. It says factor by taking out the common factor. So the first thing you want to recognize is there actually are 2 terms here. This would be term 1, x minus 2 squared. And this would be term 2, y times quantity x minus 2. Out of term 1 and term 2, they do have a common factor. What do you guys think it is? What is common to both of those? X minus 2, awesome. In fact, if I was to factor it down, this first term would be the result of x minus 2 times itself, and this one would be the result of y times x minus 2. So those of you who said x minus 2, you're correct because they share that. So we're going to factor it out. We're going to divide it out of each term. So if I divide it out of the first term, what I would be left with is x minus 2. So I'll put that in. And if I was to divide it out of the second term, which is what I need to do, what will I be left with? Good, just y. So when you divide it, you're taking it out of each term, and then you're essentially grouping what's left, the x minus 2 and the y. And then that would be my answer because there's nothing else that I can do.
So what the 2 terms share, you put in a separate like term.
Mm-hmm.
And then
if
they don't share, like if there's like an extra or like what they do.
What they don't share is what's left over inside, like you group together.
Okay.
So if I was to ask you what's x minus 2 squared divided by x minus 2, you'd say x minus 2. And then what's y times x minus 2 divided by x minus 2, y. And so that's kind of what you just leave there. Okay, that skill you need in factoring by grouping. There's 4 main steps to factoring by grouping. For this first one, we're going to do the step and then we'll write it down in words so that when you come back to it, you can see what we've done. So let's start right here with number 1. The first step is to group the first 2 terms and the last 2 terms. Here's how I group it. I just use a little squiggle to say I'm grouping those 2 and I'm grouping those 2. That's step 1. So let's go ahead and let's write it. Step 1 is to group the first 2. And then I just show how I group with that little squiggle. And last 2 terms. Step 2 is to take out the GCF of the first 2 terms. So let me go ahead and zoom in on the first 2 terms, 2x cubed minus 10x squared. What would be the GCF of those 2?
2x.
2x, awesome. 2x squared, awesome. And remember, if you weren't sure, you could always break it down. They both share, yep, 2 and then x times x. So I can break that down. I can see they share this, so I'm going to take it out front. But then when I break it down, I want to make sure to write down what's left. So out of the first one, be x, and out of the second one, it would be -5. Now that's step 2. So let's go ahead and let's write that. Step 2 is to, take out the GCF of the first 2 terms.
So would the next term be 3?
Good question. So now we're going to use a strategy here. In step 3,
But they don't really
they only share a 3, but here's how you can always figure out what they share. If you take what's in parentheses, so what's in parentheses?
Oh,
X minus 5. So if we take that, we're going to leave a space and copy over the x minus 5 to the other side. That's going to help us factor. So step 3 is really copy over x minus 5 to the other side. And you're going to use that to factor 3x minus 15. Caleb?
So pretty much like if there's ever like 4 terms, you're trying to like split them in half.
Yep.
And group them,
Yep.
like separately.
Yep. And you're trying to create a greatest common factor in them separately so that you can take it out at the end.
Okay.
So now if I'm looking here, I'm using x minus 5 to help me factor. One of the things I could look at now is what times x would keep a 3x? 3. And here's my built-in check step. Is 3 times -5 -15? Yeah. So you factored the last 2 terms. So that's step 3. I'm going to go ahead and put it off to the side here. Step 3, copy over what is in parentheses. And use it to factor the last 2 terms.
And that's only if like they share.
So if this doesn't work, then the polynomial of 4 terms is prime. It's not factorable. So this is the only method that we have to factor 4 terms.
Okay.
Now, well, at least the only one I know of. There might be something else, but this is the one that I know of. So now looking at this, again, I have 2 terms. I now have this term and I have this term. What do they share? X minus 5. So we're going to take out x minus 5. And if I take out x minus 5 from the first term, what's left?
2x squared.
Good, 2x squared, good. And from the second term, good, plus 3. So that's it. So that's step 4, is to take out the GCF. It's always what's in parentheses. So go ahead and write step 4. Take out the GCF. And then I'm going to put in parentheses,
Remaining terms.
Yep. And I just put in parentheses, it is what is in parentheses. Okay, so that first problem might have seemed long because we had to write down all those steps. Now let's try number 2, just following those steps. So step 1, group the first 2 terms and the last 2 terms. What's the GCF of the first 2 terms? Good, x squared, so we're going to take that out. And we'll be left with, what's x cubed divided by x squared? X, good. And then what's the second term? Yep, minus 2. What am I going to copy over to the other side? X minus 2.
And what you put in the parentheses, what was left over?
Yep. So if I was like factoring this down, this would be x times x times x. This would be minus 2 times x times x. And the x squared is what's shared. And notice the x and the minus 2 are what's left over. Then I'm going to ask, what times x would maintain a negative 9x? Negative 9, and here's your built-in check step. What's negative 9 times negative 2? 18. So I know that I've done it correctly. Final step is take out the GCF. What is the GCF? X minus 2, good. And then I'm going to group x squared minus 9. And then lastly, you guys just did a bell ringer of reviewing all the old type of factoring. What can x squared minus 9 go down into?
Oh, S2, X squared.
Good, x minus 3x plus 3, or reverse order, however you want to write that. So this would be the final answer. Okay, we did one with a bunch of vocabulary. We did one without that. Let's see if you can do one on your own now. So here's add number 3. Go ahead and factor. If you have x to the 5th plus x to the 4th plus 2x plus 2. Yeah.
When it comes to like taking the test, is there like a way you want us to write that out so we can like, so you're able to like differentiate the terms?
How do you mean?
Because like you do it in 2 different colors.
Oh,
Show like.
no, you can just write it in pencil.
Okay.
I'm just trying to show it like as we see it. So go ahead and try this one. If you're stuck, I'll be walking around. If you're like, what did you do here? I will come straight to you.
And then be like, yes. Yeah. Because this one won't set the place because there's like there should be another term. Well, number in the other term because
Wait, they don't.
yes.
All right, guys. One thing you want to check, x to the 4th was the GCF of these first two, and it would leave you with an x plus 1. Then I would copy over an x plus 1, and the GCF here would be 2. So then I would bring that to the outside, and my answer would be x plus 1 times x to the 4th plus 2. And that's it. Why is there just one?
Because they're grouped. Like, they share. Oh, those are the GCFs.
Oh yeah, they're GCFs. So we take that to the outside. What'd you say? Is the parenthesis order matter? Is that what you asked? No, you could have x to the 4th plus 2 first. All right, guys, the last thing we do is review factoring that you've done, but we're gonna just use some higher variables. So you've factored expressions in this form. You did a bunch of them on your bell ringer. The nice thing about factoring using trial and error is you can actually factor using degrees higher than 2. So we're going to illustrate what we've been doing using just a box. And then we're going to see that whatever you put in the box, it can be used for higher level polynomials. So let's go ahead and start right here. If I'm factoring this down, right now I would read this as a box squared plus 4 times a box plus 3. There's no GCF, so I would break this into 2 parentheses. The last term is positive. Therefore, am I going to have the same signs or different signs? Same, good. What are they the same of? Good, the middle one, plus and plus. Now, if I'm undoing the F in FOIL, let me stop and think about what it means to be something squared. 3 times 3 is 3 squared. 4 times 4 is 4 squared. 5 times 5 is 5 squared. So what times what would create a box squared? Good, a box times a box. So whatever's here and whatever here, when I multiply it by itself, it creates that box squared. So now I've undone the F. Now let's go ahead and undo the L. What times what would give me 3? Yep, 3 and 1. And if I check the OI,
One box.
yep, 1 box
4 boxes.
plus 3 boxes gives me 4 boxes. Exactly right. So 1 box plus 3 box gives me 4 boxes. So all this is illustrating here is that whatever is in the box, you can actually use it to factor. For example, I could put anything in the box. Let's say that I have actually like an a to the 3rd power and an a to the 3rd power. As long as that same value is in the box, you can use it to factor. And that would create, well, it has to be, so we'll see how that 2 comes into play.
So is it like a to the 3rd?
Well, what would this look like if it was like a mathematical expression that came to you? What is a cubed squared? It's a to the 6th.
Oh, okay. A to the.
So what this is illustrating is as long as you have like an a cubed here and an a cubed here, then you can break that down to a box plus 3 times a box plus 1, or in this case, a cubed plus 3 times a cubed plus 1. So some of us like to just not use the box and they can just jump straight to the factoring. In math, instead of a box, we use a variable to represent what should go in the box. And that variable is used as a U in all math textbooks that I've seen, and it's called U substitution. So you have to be strategic in about what am I going to replace for you? Essentially, what would go in the box? So if I look at an expression like this, a to the 4th minus 2a squared minus 3, really your goal is to see what value is being squared and is that same value next to the factor in the middle number. So that's going to be your goal. Does this match that pattern? So let's think about it. What value squared would give me a to the 4th? A squared, awesome. And then I just have to check and make sure that a squared is in this middle term because that's important to be able to factor. If it is, then you know that you can factor it. In fact, math textbooks just like to replace it. They say, let u replace a squared. Then what that turns into is now this becomes u squared minus 2u minus 3. Now it's a problem that's exactly like what you've been doing. So if I gave you this in last night's homework and I said factor it, let's go ahead and do it. There's no GCF. So looking at the last term, it's negative. Therefore, would we have different signs or same signs? Different, good, plus minus. Undo the F. What times what would give me u squared? U times u, good. What times what would give me 3? 3 and 1, but I'm going to make the 3 negative and the 1 positive so that when I check the OI, it adds up to negative 2u. What do you think the final step is if you used u substitution? You do have to check it, and it does add up to negative 2u. There's one last thing we have to do, though. Yeah, I got to put it back in. If I let u replace a squared to help me think it through, then I have to put it back in. So I'd have a squared plus 1 times a squared minus 3. And that would be the final answer. So one of the key pieces you want to see in these next 4 examples is, can you determine what we should let u replace? So if I look at letter A,
You replaced a. You replaced a.
it replaced a squared, exactly. So if I look at letter A, what should I let u replace? A squared, awesome.
So then what happens to the a?
Well, if you think about what is a squared
So it'd be like
squared,
U
So if we look at it like this, a to the fourth is really a squared squared. And since a squared is here, this is a very similar to problem to a box squared minus 2 times a box minus 48. Just instead of using a squared, we're going to let u replace everywhere we see a squared. Yep, so it'd be u squared minus 2u minus 48. It's only for trinomials. Awesome. All right, so we go ahead and we break that down. Turn to your partner, see if you guys can factor this together using u, and then we'll finish it together. Olivia, do you know what would factor down into?
Would it be u plus 6 and then u minus 8?
Awesome. Nice job.
Did you change the a to, or did you change the u to a squared? And then should I keep going? Sorry.
And then what'd you say?
Is there, like, should I keep going with the problem?
Oh,
or-
yeah. Well, I'll bring the class together. But yeah, we got it. All right, guys, you should have factored it with your partner at least to u plus 6 times u minus 8. The final step, though, we have to put a squared back in. So it should be, because we let u replace a squared. So we need to put that back into a squared plus 6 to a squared minus 8. Why did we change it in the first place? It just helps visually for us to look at it like we did last night. You don't have to, but here is one of the reasons we started with that. Let's skip B for right now and let's jump to C.
Quite a jump.
Letter C, this one, it might be really helpful to use U substitution. What would go in the box? What is being squared and what is the same in the middle? 3a minus b. So this one might be really helpful to use U substitution so that we can just visualize it easier. Because if I let u replace 3a minus b, now this becomes u squared minus 6u plus 9. And that looks easier to factor, right? Rather than trying to use 3a minus b. Do you have to? No, you don't have to use U substitution, but it can sometimes just make it easier to visualize with what we already know. So now if I break this down, the last term is positive. So would I have the same signs or different? Positive, therefore same. Good. Why is it both negative? Good. The middle one's negative. Then if I undo the F, what times what gives me U squared? Good. And if I undo the L, what times what gives me 9? 3 and 3. Does the OI check out? Yeah.
Wait, I have a question.
Yeah.
Would it not matter either way because the word,
Would it not matter? What do you mean not matter either way?
like, cancel out? No, I mean like where you put them. Like where.
Yes, it doesn't matter where I put them because it's the same. -3 and -3. Yes, good. Now, the last thing that we would have to do is put 3a minus b back in for u because we just temporarily replaced it to make it look easier. Even though we didn't have to replace it, it just kind of makes the problem look easier and then we can factor it.
So we add 3 to the end of the term.
We added 3. We just put 3a minus b back
Yeah.
in place of u.
Okay.
So now I just put that back in.
Okay.
And then that would be my answer. You could write this. In fact, your book would write this as 3a minus b minus 3 squared. Is that what you were going to say, Alyssa? Yeah. You could do either one of those would be good. Okay, so let's see how we're doing with this one. Try letter D with your partner. See if you guys can let you replace something and then factor it all the way down. So Olivia, what would you let you replace?
Maybe D5.
3a plus 5, is that what you said?
Yeah.
Yes, awesome. Because then it becomes u squared minus 18u plus 81. So now it's like easier to factor, right?
Mhm.
So then we can break that down. The last term's positive. So we're going to have the same signs. U times U would give me U squared.
Yep.
9 times 9 would give me 81. And that should add up to negative 18U.
Mhm.
And then I put that guy back in. And that gives me 3A plus 5 minus 9 times 3A. Do you guys have a 5 or a B? I thought I changed that to a B. You have a 5? Okay.
Are you allowed to write? Oh, no, because it's factoring. When you're factoring, I'm assuming you don't want us to do 3 plus 5 minus 5 squared.
You could write it like that.
Okay, because I didn't know if you wanted.
You
like,
could
factoring
also-
and trying to break it down.
Yeah. Hey guys, real quick. You could have this as 3A plus 5 minus 9 times itself, or 3A plus 5 minus 9 squared, or you could technically have it as 3A minus 4 squared. Do we know why we could have it as minus 4? Yeah, we can combine those. So 5 minus 9. Okay, so any of those are good. It means you know how to factor. But yeah, we do want to combine like terms if possible. And that's it. Your homework tonight is from P6C. And you guys have a great rest of your day.